So we've talked about the fact that in this class, given the fact that we're again sort of still drawing everything in a two-dimensional plane, typically we're going to do cross products using with the geometric version. So we'll calculate the magnitude of your first vector, magnitude of your second vector, sine of the angle between your two vectors. But we need a right-hand rule to help us figure the direction, right? So obviously a cross product gives us back a vector. A vector has a magnitude and a direction. We'll use the geometric rule for getting the magnitude. We're going to use the right-hand rule for getting the direction. So what this video is going to try to show, at least as well as I can, sort of given the online circumstances here, I'm going to try and show you guys one of several variations for the right-hand rule. So if you already know a right-hand rule, you learned one in a class in high school, you're very comfortable with it, great. Keep using that right-hand rule. If you've never seen a right-hand rule before, or you saw it and didn't really understand what it was trying to tell you, I'm going to show you what for me is sort of the simplest one. And so we'll try to get you guys comfortable using this particular right-hand rule in terms of figuring out the direction for cross products. And the cross product that we're going to care about first, of course, is the torque. So let's just do it in general. So notice I have two vectors here, vector A and vector B. And so what I'm going to do is I'm going to start by taking my thumb and I'm going to point it in the direction of vector A. So my thumb is going to point in the direction of vector A. My fingers, I'm going to hold my hand so that my fingers can point in the direction of vector B. So if what I'm doing is A cross B, that means A is your first vector, B is your second vector in the cross product. Then the right-hand rule tells you, so A, use your right hand, right? The number of times students have gotten the wrong answer because they've used their left hand, it happens all the time. So make sure you're using your right hand. Then you're going to put your thumb in the direction of vector A. You're going to hold your hand so that your fingers point in the direction of vector B. And now what you notice is, or what you want to pay attention to, is what's the direction that your palm is pushing. And in this case, notice that my palm is pushing out of the page. So out of the page, again, we've got a way to denote that. So out. Vectors that point out get the little dot, either with or without the circle. So we may do it like this, we may do it with the circle. Either of those tell me I've got a vector that points out. For in, again, with or without the circle, there's my symbol for the vector that points in. So when I think about drawing, or what my right-hand rule is telling me here, thumb with vector A, fingers with vector B, my palm is pushing out. So in this case, what I've got is I've got my palm is pushing out, which tells me that the cross product, A cross B, pushes out. That's what my right-hand rule is trying to tell. Now if we flip it around, let's say we wanted B cross A. Well, B cross A, we would now switch. And so instead of my thumb pointing in the direction of A, it would point in the direction of B. So if I want B cross A, that means my thumb now goes with B. And my fingers now point in the direction of A. And so if I hold my thumb in the direction of B, in this case pointing up, my fingers in the direction of A, now what I notice is my palm is pushing in. So the reason that we care about making sure we're good with our right-hand rule is because A cross B and B cross A point in opposite directions. And so we got to make sure that we know which direction we need, particularly since these are going to be vectors, we're going to be doing vector addition. If you don't have the right direction for a vector, it's hard to add things up.